So I sort of chose this location because it's pretty special, to say the very least. And we're going to talk about a few different things, but we'll begin by talking about what's kind of not new, but it's quite big in agriculture and horticulture as people discover its potential, but the Asians discovered it a bit earlier than we did. And it involves something called lactobacillus, and of course you've heard of lactobacillus. It's what's inside your gut. There's this tremendous parallel between soil health and the external stomach of the plant, because the plant feeds a third of all the sugar it makes. It feeds down and feeds the microbes because it knows that it can't do anything. It can't digest any residues to get food back or anything. So it's kind of an external stomach, and the plant feeds that stomach to look after those organisms. But ours, of course, is internal, and we're feeding it, and we've got this life within. But what we now understand about that model is that we've got 10 trillion cells, and we've always thought ourselves as sort of physically as a sack of 10 trillion cells, all of whom can do everything, and those cells communicate, and literally they specialise, but they can actually do everything, each cell, and that allows us, our physical being, and then we've got a separate thing called a spirit. But that's what we thought we were, and then there's this research developed into what's called the microbiome, and this discovery that you've got 100 trillion organisms, so there's 10 times more of them than there is of you. And what the recognition is that we're a kind of a joint organism, and that this life within, this 100 trillion organisms, not just in your gut, but 30-foot digestive tract filled with them, and your skin, every square inch of it is covered in lactobacillus, being the dominant of many organisms, and there are multiple strains of lactobacillus. And I think, as I said on the Tuesday night, you could say, get those filthy things off there and hop into a bath of Dettol morning and night, and you last 6 days and die. You killed your protective biofilm. So we've done very much something equivalent, not just to our outside, to our inside, in terms of, there are really basic things. If you understand the importance of your microbiome, it's now considered to be all important. Brain health is directly linked to the health of your gut. Your gut's called the second brain. Your 85% of your immune system's down there in the gut learning. So the very obvious thing is I can follow behind you in the supermarket and be quite accurately predict the health of yourself and your family. And that, what do you think that would be based upon? What would be in your trolley? The processed food. And the trolley, because food's not supposed to last for 2 years. Cornflakes is not supposed to last. Food lasts for a week or two unless you salt it, freeze it, or dry it, or ferment it. And so how does it last for 2 years? How come we've got these football field sized stadiums full of food that lasts for 2 years minimum? Because we added what sounds innocuous. We added things like sodium benzoate, food grade stabilisers. But what is a food grade stabiliser? Just asking the next question. Well, it kills single-celled microorganisms, so the food will last for 2 years. And many foods have amounts like 2.5% of a food grade stabiliser in there. Just look at the label and see the numbers and find out what those numbers are. And basically, why would you think when your child is shoveling back the cornflakes that last for 2 years on the shelf and it's got 2.5% sodium benzoate, that it stops working at the mouth? Of course it doesn't. And the more processed food you eat, the more compromised your gut system and the worse your health of yourself and your family. It's very simple. The story of nutrition and human health is just based on the closer it is to its natural form, whole foods are what you eat. There's nothing, you give me an example if you can, of anything ever that improved the nutrition of our food. There's nothing except maybe fermenting, which is a natural process anyway that can lift the value. But everything else is about depreciating the value, and it comes right down to the most basic of components like salt. Why would we take something with 74 minerals, something that whole cultures were based on how many salt mines you had, where the word salary was based on the fact that people actually got paid in salt? This perfect balance comes from the ocean, of course, originally. Even if it's a mountain salt, it was originally an ocean-based thing. The perfect balance of all 74 minerals is found in salt. And then we say, just think about how stupid it is. You're just left scratching your head. And we said, we're going to strip everything out of that and just leave sodium and chloride. And so we take out 72 minerals, and then we've got something that, high blood pressure, you're going to avoid salt. Well, you don't have to with mountain salt or sea salt, because that's just the bastardized version of it. And then we said, well, it doesn't flow that good. Sometimes it cakes. So let's add aluminium. Now, all you've got to do is Google aluminium and Alzheimer's, which is 1 in 4 people 1 in 4 people over 60 now succumb. It's a plague disease. And if you look at the root causes, and there are several, one of them, and there are over 30 published papers on it, is aluminium. So then you think about your little morning routine, because there's a new finding that fluoride triggers aluminium to do its dirty work. So you think about your morning routine. Out of your shower, grab that little stick of underarm deodorant. There's one thing and one thing only that can stop sweat cells from sweating. It's called aluminium. You might have said, oh, I went to the market and bought this little piece of rock crystal and I put water on it and rub it and it stops me sweating. Yeah, it does. It's natural aluminium sulfate, that crystal that stops you. So aluminium is the only mineral, and you take it in the most available form, in the form of a not a deodorant but an antiperspirant, and you put it right next to your breast and you're sucking it into your cells to shut down a natural process called sweating. So you hop out of the shower, you give yourself your dose of aluminium, you take your fluoridated toothpaste, at least you won't remember how you got Alzheimer's. But we know this stuff and we still do it, and we know that the food grade stabilizers are a horror show, and so, you know, it is literally, I can follow behind you and say this is how crook you're going to be or otherwise, including issues with your immune system. So the idea is to eat whole foods, and it's real simple. Eat it as it was intended before we bastardized it. And the only good thing that you can do to change that, and it really very much strongly is linked to longevity, and all of the studies of longevity have shown that every long living group, whether it's the Georgians or the Hunzas who live to 118 on average, or the longest living Asians currently, which are the Koreans, all of them ate lacto-fermented food on a daily basis. So here we're looking at the potential of lactobacillus from a food perspective, and the finding is that everything, so there's an example of something you can do to a food that improves it, but everything that's gone through lactofermentation, the value of it has increased 5-fold. So everything is uptaken 5-fold better when you put the microbes behind the minerals. So if we look at James Cook, when he sailed out to here, including Norfolk, he bought 17 barrels of sauerkraut, and they ate the last one 22 months after the first, and it was still good. First modern, there was plenty of things the Chinese did, but the first modern voyage of discovery was zero scurvy. Now, cabbage doesn't even have much vitamin C, but it's 5-fold magnified when you run it through a fermentation process. So the concept of eating a little bit of lacto-fermented food, and the real simple things like kefir, or kefir, however you want to pronounce it, is the simplest thing in the world. To have your little mother, it's called the mother, nice term, fill it up with milk, leave it on the bench. You know, a day later it's thickened, not as thick as yogurt, but like a runny yogurt. You just drink that top half, or add some fruit to it or whatever you choose, and leave this much and top it up again. You can have a glass for each family member, and it's quite a lot more comprehensive than yogurt. Yogurt's good, but kefir's much better. And so that's just how simple it can be to bring some fermented food into your equation. But when we talk about the importance of the life within, a great example of it is this current, quite recent preoccupation with looking at things called fecal transplants. So the concept is that, I think I touched upon this on Tuesday night, you find someone bomb-proof, and there's a whole screening thing. So these are people who just don't get ill when everyone else does. They've got this really robust immune system, and it's usually a familial link that they've got this amazing life within that has boosted their immune system and improved their health generally. And you pay that person to poo. So $400, 2 poos a day, pretty good, 7 days a week, do the sums. I don't know how you describe your job, but and then you take the person who's compromised in whatever way, and you nuke them. And it's not just an antibiotic, there's about 10 antibiotics, because you've got a whole community. It's not just acidophilus in the top half and bifidus in the bottom. It's way more complex than that. It's very much like the soil. There's multiple strains and species, and you kill the whole shooting box. And then you brew that person's poo, and you put a tube up their bottom, and you transfer someone else's complete microbiome into your body. And it's just ridiculous, the effects of it. The study at one of the recent conferences I spoke about, I think I also touched on Tuesday, was relative to manic depression, long-term bipolar disorder. And we're talking long-term, people that had 20 years, and nuking them, replacing it with a bomb-proof gut, and 82.4% complete cure rate for long-term manic depression. So do you start to understand how you might call the gut the second brain? it's mind-boggling when you think of it. So if you realise that you've got this hugely important system within you, then you start developing perhaps a little reverence for what you're putting into it to knock it round. You can boost it with what are called, probiotics, or you can eat certain foods that are called prebiotics. Now, what I think would do wonderfully well here on the island is, I'll just take this thing out so I can tie it on. What I think would do, sorry, get this sorted. There's a root vegetable, I'm not sure if you've heard of it here, that's called yacon. Who's heard of yacon before? Oh, you have?
Yeah, I've got some.
Have you? So yacon is really, you could qualify as a superfood. It's an overused term, but the queen of prebiotic foods. So the two most researched prebiotics are called inulin and fructooligosaccharides, and these are foods that feed up your good guys in your gut. And Jerusalem artichoke has been the queen of prebiotics forever until they discovered yacons, this South American from Peruvian apple they call it. And it's a member of the sunflower family, grows to a couple of feet high, a couple of metres high, has these roots that look like sweet potatoes on the base, and those sweet potatoes are the most delicious flavour, particularly if you let them dry right back, because that's when they pump all the sugars in there. And they taste like a cross between an apple and a pear, but more juicy. And you eat them raw, or you can bake them, or do whatever. You can dry them, dehydrate them, and they're delicious. But they're double the Jerusalem artichoke. They're just like pure gut medicine. And understand, if you've got a dehydrator and you dry things, the drying process quadruples whatever the nutrient concentration is and whatever you're drying. So you've got 4 times more of whatever. You dry a tomato, you've got 4 times more lycopene. It quadruples the concentration. So drying's a pretty cool thing to do. And with yacons, they dry into this. We should have brought some, but we do it as a commercial crop. But we've got big commercial dryers and we dry them, and they're just this kind of a sweet, savoury, biltongy, chewy thing that's just absolutely delicious. You have it with a glass of wine or a beer or whatever, and it's quadrupled that prebiotic effect.
Well, I mean, we put in 10 kilos in the dryer and get out 1 kilo of dried yacon.
Yeah, so it's actually a 10 times concentrate. Yes, a 10-fold concentrate.
To eat the fresh yacon is really different to eating the dried yacon. It's quite different because it's got 10 times the power in it.
Yeah, it is. It's amazing.
And if anybody ever does it, if you are growing the crop and you are drying it, I suggest dry it and then have a good look, dry it further than what you would, just a little bit, because it's soaked, and then pull it out of your dryer. Don't leave it sit in the dryer. You know how apples are fine to have it sitting for 24 or 48 hours, but it will soak the moisture back in. So they're really moist and they really are soaking. If they sit, when they're finished, they need to be put away.
So we put them in little 150 gram bags and they're sold as yak snacks. It's part of the kind of value adding that I try and teach people. But we've got maybe 5,000 of these plants in, and you get about 5 kilos per plant. So they're a tremendous crop.
Would you be able to bring them in here?
Yeah, well apparently there's some here. Yeah.
And with cooking them.
So they have as far as a cash crop goes, they have 2 income streams. They've got that tuber, about 5 kilos per plant if you've done it well. I've got a friend who's got 22 kilos from one plant, but 5 kilos is the average, sometimes slightly less. But there's a second thing, there's a little red knobbly thing. So the root comes down and it joins onto this red knobbly thing called a rhizome, and then hanging off that is this sweet potato-like tuber, but it's like an apple. And you just eat it raw, and that rhizome sells for $29 a kilo, and there's quite a big demand for it. So you've got 2 income streams. You get 2 kilos maybe of rhizomes on a big plant. So you get 5 kids, we get $6 a kilo, is $30 plus $50 for the, so maybe 80 might be a stretch, and it's $70 per plant. That's a pretty good cash crop. Has no diseases. So it's really worth.
The rhizomes are just for propagating the plant.
Yeah, only you can't grow from the tuber, you can only grow from the rhizome.
Have you had a full season of them yet?
I haven't.
Yeah.
I planted it really in the wrong spot, so it didn't do too well.
Yeah, well, I mean, we've got 2 different places where we're growing them. So up in Yandina and then in Applethorpe. Now in Applethorpe we had a really nice crop, it's sandy soil. Yandina is very
clay, high,
similar to this
yeah, similar,
one.
but clay soils, yeah.
They make huge amounts of rhizomes, but not so many yacons. It's really interesting. What happened here?
Some places you get lots of propagating material,
Yeah.
but not much of the
Yeah.
Yeah.
tuber. That's
Yeah.
weird.
So
About 4.5, 5 months. So similar to turmeric and ginger and so forth, but shorter than ginger.
But they sit in the ground.
But they like that they die off at the first frost. I mean, you don't even get frost here, but they just die off naturally when it gets to winter. They grow amazingly well here. We just did this broadacre field day. It's called Victorian No-Till, who've adopted all my principles on our 2 million acres, who are outperforming everyone in the region. And one of the tricks that they didn't pick up from me, but it's a great trick. This guy has got one brewing room doing anaerobic brews like this, 160,000 litres at one hit. And I thought that was the biggest I'd ever seen. There's another guy, and I've just come back from training their group, they're called Tiverton. They've got 450,000 litres in huge tankers that take it out to their farm. So this is kind of the shape of where we're heading, these biological fertilisers, these cheap, inexpensive, do-it-yourself. But one of the tricks, and I'll just say this and then I'll answer your question, they take cow rumen, which you could access here, not rumen, paunch, which is the undigested, the early stages of digestion when you kill a cow. It's that big sort of bag full of half-digested grass, and that is incredibly intense because this is the start of digestion. You've pumped everything in terms of your rumen organisms in there to begin that digestion, and you can take that and you put milk powder and molasses into an anaerobic tank on whatever scale you want to make that anaerobic tank, and they brew that until it reaches pH 3.5. And you've got, so the way that it's done really simply on a larger scale is that you would take that rumen, you would take the milk powder, you take the molasses, and you put it in a 1,000 litre shuttle or a 200 litre drum on a slightly smaller scale. And with the 1,000 litre tank, the very simple way you do it is that you drill a hole in the lid. So you can buy them, and we give them away, or $80 I think we sell them for. But you get hold of one of those, and you drill a hole, 12 mil hole in the lid. You get a 1 metre length of hose. You put one length of hose through that hole in the lid into the empty space. So there's about that much, and when you fill it up, there's a mark saying 1,000 litres, and you've got that much space. So in the space, not on the water, you want to capture the CO2. This is the one-way valve on a larger scale that you're creating. The other end of the hose, you get a 2 litre Coke bottle, fill it with water, strap it 2/3 of the way up on the metal frame with a couple of plastic ties, and then you put the other end of the hose into the bottom of that bottle, and as the organisms go to work and start brewing, they bubble. So we do that that's how we do a larger lactobacillus tea, for example, or BAM, we'd brew the same way, or this concept of taking the paunch with the molasses and the milk powder and let it bubble, and when it stops bubbling, when the bottle stops going gloop, gloop, it's finished, and it will last for 2 years sitting in the paddock before it's stable, and you can use it with anything. Now that's a cheap fertiliser, and they're out yielding everyone. They put it out as a liquid inject. As they plant the seed, they put 20 litres a hectare of this paunch brew that they do, or they do, a lactobacillus tea or whatever, but nothing when they foliar spray, when they do a leaf test and say, what do you want, plant? Oh, that's what you want. And you foliar spray it, which is through the leaf with the big machines. You always put one of these microbes that's got this long stability, like BAM or this thing here, this lactobacillus tea, or this paunch tea. That goes with the nutrients, and that, of course, the stomate opens because it's releasing CO2, and you get this much better efficiency of the nutrition you're using. So anyone can do that at a home level or a farm level for you, and it's just a wonderful strategy. Now,
do you want to do the worm thing next? Because it has to sit.
Okay, so
yeah, so we've got here, we have worm tea.
Okay.
This is the leacher.
So this is the stuff we talked about, how you can have worm farms, and Phil's got a couple of small ones up where he does his seedlings, and this is the liquid that drips through, and that's what people have used forever as a good fertiliser, and it is, but it's not as good, and we're going to demonstrate that with a meter in a moment. It's not as good as the concept of an extract. So we've taken some of the castings, you can see the castings from Phil's little bed, and on a small scale we're going to show the concept of an extract versus the drip through.
A
little bit more.
Using Graeme.
And then we just do this very vigorous stirring of that. And what you're doing basically is forcing that huge diversity of organisms who are where they want to be. They don't want to be in the leach aid. They're just a few unfortunate things that drip through. This is where the food is. This is your home base. This is the humus that you created and supports you. And with a hose, you'd blast it in a bucket.
Or even a pressure hose, or whisk. Like this is very basic what we're doing. Yeah?
But the hose does it really well. You just put it in real good pressure and blast it off. and then you let it settle out, or you use a stocking if you're in a home garden thing because you don't want to clog your watering can or whatever. But what we'll demonstrate with the meter is the difference between the leachate versus the extract, just so you can see for yourself. Just let it settle out for a bit and we'll just take some liquid from the top.
This is like chocolate fudge. It's amazing. All right, settle it
Okay,
down.
so we'll let that settle for a minute. Before we do that, we'll talk about an interesting additive for composts, or in the case of these little towers, and I'll talk about what that's about. So there's a brilliant researcher, his name's Professor Phil Callahan. He's got 6 doctorate degrees. So the problem about specialising is that you learn more and more and more about less and less and less till you know everything about nothing. I mean, that's pretty cynical. But having that multidisciplinary cross the border and you can think outside the box thing is a tremendous asset. And as I mentioned, I think on Tuesday night, Phil was a man who discovered the root cause, the root purpose of insects in the scheme of things. He showed that he was the first to show that plants emit an infrared radiation. A healthy, well-balanced plant sends a steady flow. An unbalanced plant, particularly if you've overdone nitrogen, which goes in with water, dilutes the plant, sends a staccato, or a neglected plant sends a staccato flow. And the feelers on insects aren't feelers. They're incredibly complex antennae that make a television aerial look like a kindergarten toy when you see them blown up. They're just huge, and they're all different, but they're all unmistakable, hugely complex antennae. And they use those antennae to pick up things like pheromones, which tells you who you can mate with, which is important. But probably more importantly, or as importantly, you determine what you're going to eat by those infrared radiations. So a sick or over nitrogen applied plant, or just a neglected plant, sends the staccato, and a healthy plant that you've done well with, that's vibrant and growing and doing really well and really healthy, and high bricks is the guideline. The insect flies over with his antenna and says no. He picks up the steady vibration, infrared radiation, and says no, that's not me, and flies over. And an unbalanced plant, the insect says yes, and then he comes to perform his role in the scheme of things. And his role in the scheme of things, he's a garbage collector. He's there to improve the overall gene pool by taking out the rubbish. And you will never see an exception, as I also said on Tuesday night. You've got a paddock with insect pressure and a paddock with no insect pressure, that will have a lower Brix level. Brix level is a measure of dissolved solids, of nutrient density, and the lower the Brix level, the higher the insect pressure, and that's just insects coming to do their job. And so this penny dropping experience of people is, so if I can lift the quality of my crop and lift the Brix level above 12, which is the magical figure, that means I won't have insects. Yes, it does, directly. And you'll see, you can go online and see whole fields in the midst of a locust plague that have been obliterated, and there's a completely untouched field. That's the high Brix field. There's lots of examples of it online. That's the phenomenon at work. And I also mentioned on Tuesday night the example of my neighbours who loved gardening, and I let them use my bore because their bore was shallow and mine was deeper, and they loved brassicas, and I would use it during my pest management day of my 4 or 5 day course, and I'd grab some of their caterpillars. They had lots of problems with caterpillars. Their Brix of their cabbage was only 4. My cabbages are 17, because I sort of knew a bit more about what I was doing. 0 caterpillars on my caterpillar. So I'd take my leaves, their caterpillars, put them in a jar, put some holes in the jar and leave it sitting. I did this 5 times over 5 different courses, and by lunchtime every caterpillar's dead. How's that happened? It's not because they couldn't breathe, it's because when they eat, which they would never choose, your only role is reproduction. The nature is all about the reproductive initiative. Everything's about reproducing, and you've got the equipment to say yes, that's good food for my baby, and they didn't land on mine. Because what happens when you consume particularly the high sugar component, which is part of the Brix and the nutrient density, a big part of it, the sugar turns to alcohol and poisons the baby. And that's exactly what happened. They had nothing, no choice but to eat the high Brix leaf, and they died when they ate it because the sugar converted to alcohol and killed them. The mother would never have laid there, and she didn't, because you wouldn't lay where you're going to kill your baby, and your feelers tell you where to lay. So it's quite an interesting understanding. But Phil considered that his more important contribution, he's got 22 books, so he's got lots of contributions, was the discovery of something called paramagnetism. Now I'm interested just to test, because I've never done it, Norfolk soils and see where they're at. But basically his findings were that the most productive soils on the planet are volcanic soils. And when he came to explain why is that, he could take a non-volcanic soil and mirror every parameter. Same soil, sand, clay, same mineral component. You could brew the microbes from it, put them in there, so it's as close as you can get for the volcanic soil, and yet the volcanic soil always outperformed no matter what you did. And so he started hypothesizing and theorizing, and he came up with this concept of this, what was already known in physics, called paramagnetism. And paramagnetism is kind of a low-level magnetic attraction, and he decided that he theorized and then later proved that volcanic soils are highly paramagnetic, which means they've got this capacity, an antenna-like capacity, to pull in energy from the atmosphere. And it's not some kind of weird airy-fairy thing. The atmosphere is filled with well, we know it's filled with television waves, for example, and radio waves. And, you know, like if you took someone into a lounge and on your walls a square flat box with someone talking in real time from 10,000 kilometres away, they would have taken you out and burnt you as a witch. I mean, how the hell is that even happening? It is quite remarkable, you've got to admit. Well, you know, of course you've got radio waves, you've got Radio Norfolk. Well, there's a thing called extra long frequency radio waves, which are an energy form that comes from lightning bolts. So at any given moment, every minute somewhere on the planet is 4,000 lightning bolts happening, and when a lightning bolt happens, that energy, no energy disappears, it turns into a different energy form, and what it turns into is extra long frequency radio waves, which the atmosphere is full of. So volcanic soils, he theorized, can pull in this energy, then convert it to these tiny little light particles called biophotons, and effectively provide light for the roots and the organisms around the roots, and they go into hyperdrive, and that's why volcanic soils do better. So that's a nice theory. Then he decided he would take the most paramagnetic of materials is basalt rock, that, you know, blue metal that you use on the roads, and it varies depending on where it came from in the original volcanic eruption on how paramagnetic it is. But he took some highly paramagnetic rock to the founder of these tiny light particles, a guy called Professor Fritz Popp, and he arrives in Hamburg. He's the only man in the world who's got machines that measure via photon these little light particle emissions. €500,000 machine, and he's the only guy with it at that point. So he knocked on the door and said, look, I want you to measure this rock. And the guy said, why am I going to put a rock under my €500,000 machine? And then he realised who he was talking to, this wonderfully prestigious guy with 232 published papers and 22 books and all sorts of awards. He hadn't introduced himself beforehand, so he explained who he was and what he was doing. So he puts it under there and is amazed to find that every microsecond, every millionth of a second, there are 4,000 light particles, biophotons, measurable light particles coming off that rock. And yes, he was so excited he'd proved it. Then he's home, not home, but back in the hotel room, and he's saying, well, you know, I know that if you put compost with this crusher dust, the compost just does something crazy. I wonder. So he went and bought some compost, and he bought a hammer, and he crushed up his rock, and he put the crusher dust into the compost, and he took it back to Fritz before he flew out at 2 o'clock the next afternoon. And to the amazement of Fritz, who said, first you bring me rock, now you bring me dirt, and then he explained what it was. 4,000 went to 400,000 light particles pouring out. So there's a synergistic response when you put microbes into that scenario, and then there's this sudden explosion of light. Now what Phil used to do to demonstrate it was he took the old school 35mm cameras, he put a pinhole in the lens cover on the pinhole, and put it on that slow shutter in a dark drawer with the paramagnetic rock strapped onto it. Then he develops that film, and there's just a huge ball of light. And that's what it's doing. And so this is the whole concept of, so theoretically we're talking about super volcanic soils here, and I want to see what they measure. So I brought the meter. This is called a PCSM meter. It's the Phil Callahan's own meter for determining the paramagnetic quality, and it's like a fertility meter. Like basically the higher the paramagnetic quality, the better it does. Now you can improve it, of course, by putting minerals that are missing in there, but the higher, it's a fertility meter, the higher the fertility. And
Graeme, my wife can't hear you because you've come farther forward.
Okay, I'll step back a bit. Yeah, so basically this crusher dust, this highly paramagnetic crusher dust, is a wonderful, inexpensive fertiliser, and we offer a free service in Australia that you can send in your local quarry crusher dust, because it all varies, and it needs to be above what's, you know, it's a reading called CGS, which is centimetres per gram per second. Something moves to a magnet. It needs to be above 1,600 to be really worthwhile to pay for freight and things, but you're only paying $20 a tonne for it, and oh my God, what a cheap fertiliser if you get a good one. And so people send them in all the time, and sometimes you find a really good one. I say, where'd you get that from? So I know. And so we would never make a compost without putting crusher dust in it. Now what Phil's got, I mentioned this concept of a broadcasting tower, and I mentioned biodynamics, which is kind of a form of homeopathic agriculture, and they've developed all these preps, like the one you may have heard of is a cow horn. You fill it up with manure, you put a little clay cap on the end of it, and you bury it at a very precise time based on where the moon and stars are, because he believed in celestial influences. And then at a very precise time you dig it up, and you got a little bit of compost. You got a little bit of compost in the cow manure. You think, big deal. That's called 500. That formula. Then you take that and you put it into a vat, and again at a precise time when you put it out, and you stir it and create a vortex. Now the idea of a vortex is the path of least resistance. And if you've got an atmosphere filled with energy, which you do have, I mean, it was called, Aristotle called it ether, and the quantum physicists call it scalar energy. Atmosphere is filled with energy, everything's vibrating, everything has a unique vibrational signature, but the atmosphere has huge amounts of vibrational energy, and the vortex allows that energy to move in with the least resistance. That's the whole deal. At one point we had a point at which we could have powered ourselves with implosion or explosion. And Nikola Tesla, who when Einstein was asked in 1955, what does it feel like to be the brightest man on the planet, he said, I don't know, ask Nikola Tesla. And of course the Tesla car is just copying that name of the most brilliant man that ever walked. And Nikola Tesla and an Austrian bloke called Schauberger, they worked on implosion theory. And that's just saying, okay, you've got perpetual energy. If you create a vortex, and the vortex is falling, that's an energy form, and you're mining that energy. And Schauberger created, you can go online and see it, Hitler took him and absconded him and forced him to do research, and there's a photo of Hitler standing in Hamburg in an old colonial square, and above them is a fine saucer probably 40 metres across, powered by implosion technology, and then Hitler burnt and destroyed all the plans for it. But Tesla's, everyone's trying to recreate some of Tesla's amazing work, and he just took the name Elon Musk for the car, but Tesla was just mind-boggling. So what the biodynamic people have done is there's a huge difference between living water and dead water, and this was Schauberger's whole thing. And living water is water that has eddies, has the flow, this vortex, and then it has a reverse vortex, so you're pulling in this ether or scalar energy or whatever, and that water is hugely different. Something sits in a dam or something, you're pumping straight pipes, and the curve and flow of normal rivers before we straighten them, and the overhang of water that cools it magnifies that effect. So what the biodynamic people did was it's actually a hugely geometric process in developing exactly the right formation, but they created these things called flow forms. Water comes in, you pump it up, comes from one end, creates a vortex, a very precise geometric size to create that perfect vortex, comes down to the next one, reverse vortex, you're energizing the water like a river would have done. Down the next side. Now you can say, oh, you can only do that with BD preps. No, you can't. You can do anything with anything. I can take urea and humic acid or a trace mineral mix or a kelp fertilizer, run it through one of these vortexes, one of these flow forms as they're called, which are beautiful. It's a waterfall, and you're capturing the liquid, and you can do it more than once and magnify it, and then you foliar spray it out or fertigate it, and there's chalk and cheese difference. We've done it. We've done the research. It absolutely works. So you don't shut your mind to anything. So the idea in biodynamics, you've got these preps, some of them are herbal based, and you put them out at precise times. And what Hugh Lovell came up with was the concept of a broadcasting tower where you take the little preps and put them in a glass bottle, and you put the ones that are relative to what he called atmospheric management, which is photosynthesis, where 95% of everything comes from photosynthesis. So 502, which is a silica-based quartz, micronized quartz material, that's for photosynthesis. And so instead of spraying them out, and that's a bit labour intensive at varying times during the season, you just broadcast them with this tower, which you plant on a triple ley line. As I mentioned, every pulpit is based on a triple ley line, so you've got this energy, but you don't stay there for more than half an hour for the salmon because you get exhausted. That's why the Aboriginals won't sleep in a house with a triple ley line. But your dowse for a triple ley line, you've got someone who can do it. Hugh Lovell usually did it for most people when he set up the towers. And then you broadcast out those BD preps. Now, he gave me one for Christmas. He's a mate of mine. He came over and he stayed at my place for a bit and gave me one of these towers. So I'm sceptical because I come from a science background. So he gave me all the preps. He went out to the farm I had at that point, this 280 acre farm. He said, and it was based on a ex-dairy farm that now become a neglected beef property. Half of it had been converted by the owner, still had, and he sold the other half. I had 280, he had 220 acres. So identical history, which is perfect. So we put all the BD preps in there. I think, well, if it's going to work, it's going to work with anything. So I'm going to do the mineral test, and if it leaves some calcium, I'm going to put a little bit of calcium. If it needs some protozoa, I'll put some protozoa or mycorrhizal fungi. Do a leaf test, do a soil life test, do a soil test, and we packed. We had to take smaller vials. Doesn't matter because it's just about the energy. It don't have to be lots of it. Packed them with everything that was required. Had to choose what should go in the bottom vial for the soil and what should go in the top. You open this little pocket and you put them in there. Then I said, how do you program this thing? It can do 2,000 acres or a row of radishes. He said the owner of the property takes a map, marks the property area, and then writes in his writing or her writing, I ask that only the area within the treated boundaries be treated, thank you. And then you roll out that piece of paper and broadcast your intent over the paddock. Now, for a scientific person, that was a big push for me. But I said, what? You said the big lesson, or we'll talk about the big lesson shortly. So I did it. I put everything in there, and then I monitored. Every week I tested. It costs a lot. I had an agronomist out there every week. We measured every measurable parameter. So I did my paddock and had his for the control. 3 shades green, 6 weeks later, green on my side of the fence, on the fence line. 4 natural legumes sprung up on my paddock that didn't grow through the fence line. Every measurable parameter, including soil life, increased, and then there was a storm, a tree crashed and broke it. But 3 months of someone's got to research this stuff, and you never close your mind to anything because you're the loser. There's no one can lose from a closed mind. In a world of nothing, the only thing certain in this current world is constant change, and the most important thing is to have an open mind and just check everything. And if you don't, there's only one person who's going to lose, and that's you. You can say, oh, that's a load of bullshit, but it's not. Test it, and you don't write off anything. And so what this is what he's got on this farm is a really, so I'll just continue that story. Biodynamics has another thing called peppering, where you take your offending rat, which I'd love to see done on this island, or whatever. The problem is, in this case, the guy that stood up in my class was a Tasmanian cherry grower and a huge scale grower with millions of dollars worth of product. And they were losing 27% to crows. And, like serious, they put up gas guns and that worked, and they only lost 5%. And then the neighbours said, this is no good, we don't want this bang going off every 10 minutes all day. So they put a petition in and banned them. So they're shooting them and they can't control it. And he's losing 2.8 million, I think, or 2.4 million or something of cherries from the crows. And someone says, why don't you shoot a couple of crows, send it to the Biodynamic Institute in Melbourne, they'll ash them for you and they'll tell you how to put it out. So he sends them off in a shoebox, and it comes back in a smaller box of ash. And they say you do it at this time, and he borrowed a reverse stirrer which activates it, pulls in that energy into it, and then he sprayed it out. And he's a conventional chemical guy, and he stood up in the class and said, you need to know there hasn't been a crow on my place in 17 months. So and someone's got to look at this stuff. There's no money, so no one's going to, no one can make anything from it, but that's why you don't close your mind. That's the possibility. So peppering, I've got a very good friend and a very, very good grower, Ian, who grows avos and lychees, and his problem was bats, and the bats are absolutely obliterating these giant Chinese third generation. His great grandfather planted them, the biggest lychee trees you've ever seen. I don't know what variety it is, it's a Chinese variety, but smothered in 3.5 tons per tree of lychees, if you can imagine that. And the bats take about 80% of it. So he decided that he would pepper a bat with he's got one of the broadcasting towers that send out the permanent vibration that you put in there. And interesting, the moment Hugh Love came out to his farm and told him where to put it and sold him the unit, and the moment he put it up, the cows, which had never gone to that hillside, all sat next to it each night. So they know something's happening, whatever that is, and he had to put a little fence around it because they were rubbing against it. But you're not allowed to kill bats, even though they blacken the sky and take everything that you've grown. So a bat had an accident and ended up in his barbecue, and he turned it back into an ash, and he put the ash vial in and broadcast the ash, and that night he had half the normal damage. And he thought, wonder why only half, and then he realised there was a brown bat and a black bat. So the black bat then had an accident, and since then, which is 18 months later, he's got complete control of bats. As I said, you don't close your mind to anything. Something is happening worthy of further investigation there, to say the very least. So what we'll look at is what they've done in the simple version is take this with a triple A line. Who was it that dowsed? Trev Calder. So he dows, and Phil's got 2 of them, and then he filled it with paramagnetic crusher dust, and so you're putting out that paramagnetic energy, broadcasting it via the triple ley line, driving it out in all areas around it. But Trevor suggested that you could put rat ash in there and do the same thing, but Phil's not tried it. It's certainly worth a try. You got some now, have you? Good. It'd be interesting to see if it does anything. Thank you. Okay. So we'll just quickly show you the, well, first of all, we'll just do this. Oh, we can do that now. Yeah.
But then it takes 20 minutes.
Have you got the program and everything?
Program? This one?
No, have you got the program on your TV?
Well, I've got it here, and I'm connected to some sort of internet Phil gave me.
Oh, that's good, you're right.
But then it says to me, not connected to the internet. I don't know. Do a trick. It was supposed to be connected with this.
Just ask Phil just a second.
Where is he? He's not here.
Yeah, no, he's just in the back there.
No, this is the other Phil.
Oh no, just ask Phil because whether he can do it, whether he's got service out here. Hey Phil, have you got service out here? So this little, we're going to do a microbiometer test which measures the total microbial biomass and the difference between the leachate and the compost, and we could do some soils and see how they are as well. But you've got to have this little app, you've got to have internet service to operate it.
I'm not sure. Probably.
Has he got the app on his? Has he got the app on his?
I'm not, he gave me this and said this is all ready to go.
Okay,
But now I'm trying to.
See if you pick up my name on the Wi-Fi. Go to your Wi-Fi.
This is me.
So anyway, I'll continue, I'll talk through the thing as we go. So the starting point is
Now there's my password.
that you take this much water, so we'll just fill it up from here, and ideally that would be deionized water because you don't really want the mineral component, but it's not hugely important for this particular test. So then you take a test tube, and that's the exact amount of water because it's quite precise, and you pour that into the test tube, and the test tube just sits like so, and then you take, so it's a woman who's got 5 patents for blood, and she's made millions of dollars from developing some things she can measure in blood that you couldn't measure previously. And she retired, and she realised then when she got fascinated with this little farm she had that there's no way of measuring microbes that really do everything, and obviously it would be a good thing to have an inexpensive way of measuring them. You can do it for $400 at a lab. She wanted an in-field way to do it, so she developed this tool that's gone on to become a global phenomenon. But unfortunately, well, she got to see the scale at which it went, but then she died about a month ago. So, but she did create something very special. So this is her concoction of powder that you put into this, into that prescribed amount of water. And then in the kit comes these kits are like $200 and something. It's got a little stirring machine. And you leave it for a few seconds and dissolve that powder. Then you take either a compost tea or an extract or some soil right beside the roots, because all the organisms crowd by the roots because they get fed by the plant. You want the highest count that you can get to get an indication of your soil at its very best. And you take just a little bit of that soil. I'll just see if that's done it yet. Yeah, that's dissolved it all. So you take a little bit of soil. We might.
I've got 2 different. I'm not interfering, but I've got 2. This is the worm extract tea,
okay.
tea, and this one here is the worm from the actual.
So I'll get 2 of these test tubes going at once.
2 of those. There's another one ready.
Yeah, but there's none other test tube in there. Oh yeah, there's one.
No, this is it. I've got it here ready.
Oh, you got it ready. Thank you.
Yeah, but I haven't put the powder in.
So I'll put the water in now.
Powder? That's the powder going after the water?
Yep.
Yeah.
Right.
Stirry. And then How much of this do we put in?
Just 3 drops, same as what you're doing normally on
Okay,
those
so,
little cards.
So on this one here, Graeme, I'll extract some of this out into this jar. So we
Okay.
don't have too many bits, or what do you
Yeah,
want to
that'll
do?
be good. Just a little bit. Just take the very liquidy form. As long as it's something that will go through there. Yeah, that'll work nicely. That's enough to be able to squirt some up. And there's a little bit left in the bottom there. Mustn't have had it right to the base.
Because if he only wants 3 drops.
Does that do whipped cream too?
Yeah, it can.
So we could
That's got it.
probably use the same pipette, do this one first.
Yeah, and then we could use a different pivot for the second one.
Yeah.
Yeah.
So how long have we got to leave this then?
So no, we put this in there first and then leave it for 20
Yeah.
minutes.
Yeah. So, what, 3 drops?
No, you can. No, the 3 drops is what we take out at the end. You can put, you can put a reasonable amount into that.
Oh, I see.
So usually it would be that 1 gram.
So
we
this
could
is-
just
this
do the 1 gram. Remember
How are
filling
you
this
going
up
to do that?
by sucking that up to 1
You
gram.
can't, it won't suck up, darling.
You watch.
How's it going to suck up?
Just did. That's half of what we need. And I'll just do that same amount again.
Okay.
Yep, that's the other half.
So the one on this side is the lychee.
I just have to need a little bit more than that. It's not quite a gram.
Here, we can use this and fill it up. Just make that a gram wide and I'll fill it up with this.
Oh yeah, that's a good idea. It's half a gram actually, so it's there. That's perfect. And we need a little bit more than with that pipette of that one because there wasn't quite enough.
Oh.
So about half of what we put in then.
Well, how much would you like to add in there?
Just put it in. Yeah, that's a couple more drops, that's about right, just about the same amount for the steps wise, that's it. Then we stir this 30 seconds and then we stir that for 30 seconds, then we wait for 20 minutes. Then you click on the app and it activates your camera and the light comes out of the camera and this chemical concoction embodies all the microbes and the light refracts off the embodied microbes and there's some kind of app in there that analyses how many what the total biomass of microbes is. But not only does it tell you
How much?
30 seconds,
Well, I don't know.
that's 20 more left.
So then we've got to put, I'll probably need your timer.
So not only does it come up with the reading, first of all, there's this little square that you put a few drops of that solution on after 20 minutes, and then the camera has a square on it inside your camera, and you've got to line up the 2 squares. It's just too far, too close, and then a reading comes up of total microbial biomass, and not on these liquids, but on the soil. It will also give the fungi to bacteria ratio. Now, what's interesting about that ratio is that I was at New Zealand at this talk with Nicole Masters, a 5-day course. We had 250 growers. We brought in farmers from 5 countries, England, the UK, the US, Australia, and New Zealand, and they all were quite large-scale farmers in varying enterprises, including grazing, and they all had the same story. They had all different stories, but their central component, the common denominator for every one of them, was that when they improved their fungi to bacteria ratio, everything turned around, including their profitability and their farming fund. It's that important. It's the single most important ratio, and the reason for that, well, there's several reasons, but when you're growing crops, you're managing 2 things. It's quite simple, it's just not that simple, but basically you are a manager of 2 things, and the better you manage those 2 things, the more vibrant, the more profitable, and more fun you'll have growing that crop. So the 2 things, number 1 is called gas exchange. You're managing gas exchange. Now, what is gas exchange? The most important nutrient for everything living is not N, it's not P, it's not K, it's not calcium. It's called oxygen. You know that yourself. 2 minutes with no oxygen, you're done. All carbon-based life forms are oxygen dependent. So how well your soil can breathe is called gas exchange. So it's not just about oxygen, which the atmosphere is filled with, and there's a phenomenon called diffusion where high concentrations automatically move to low concentrations. So the high concentration, if your soil is friable and open, moves into the root zone. The microbes, the plants use it for everything. Oxygen drives everything, and then they breathe out. and they breathe out CO2, and now you've got a concentration of CO2, so it diffuses, and the plant leaves waiting with the tiny little mouths and combines it with water and sunlight in this almost miraculous process that builds the building block of everything, photosynthesis that builds glucose that grows everything, and that's how you grow stuff. And the better the oxygen comes in and the CO2 comes out, and that's why it's called gas exchange, the better you do. So then you say, okay, well, what determines gas exchange? How can I be better at it? Two things. Number one is the calcium to magnesium ratio. And why is that important? Why is it important that the island's so deficient in calcium? And it might be worth correcting in some instances, even if it's just localized around the roots. Calcium, all minerals are a different size, and calcium's the biggest. It's called ionic radius. It just means the distance across the circle. And calcium's like a beach ball, and it has two positive charges. It's called a divalent cation. It's just this name, divalent means it's got two charges. So that big ball with two charges is held in the soil by clay, which has negatively charged Velcro sites that grab hold of positively charged things. So on one side of that big ball, there's two charges, if you can picture it, charge here and a charge there. You grab a little particle of clay because it's negatively charged, and on the other side you grab another little particle of clay, and the big ball pushes apart the clay, and in comes the oxygen, and out comes the CO2. That's called flocculation. That's what calcium does. Opens up a soil so it can breathe. So the calcium to magnesium ratio, magnesium is a golf ball compared to a beach ball with two charges, and it grabs the clay and pulls it in. Now you've got these tight closed soils, you've got platform boots in the wet. They call it a Sunday soil. You work it Saturday, you plant it Sunday, Monday, it's already tightened over, and that's high magnesium. So the calcium to, and you can say, well, forget the magnesium, I'll just do the calcium and open her up and let her breathe. But you can't forget the magnesium, because herein comes your second role. Your second role is that you're a chlorophyll manager. You're managing that green pigment called chlorophyll, and you never want to have stripes or blotches or pale colours or burnt edges or whatever. That's called chlorosis, those stripes and pale colours and blotches, and that's a lack of sugar factories, because the chlorophyll contains the chloroplasts that make the glucose that grows stuff. So obviously it's got pale colours and blotches and stripes, you've done a bad job, you've missed the trace mineral or whatever that's created that, and so you're managing chlorophyll and you're managing gas exchange. And when you say, well, what's magnesium got to do with it? The centerpiece of chlorophyll is magnesium. It has nitrogen tagged onto it, but structurally it's magnesium with 4 nitrogens on it. So that's why green is always called nitrogen, because there's 4 nitrogens there. But you can have all the nitrogen in the world, if you haven't got magnesium, what does it tag onto? So magnesium's huge, and so there's a ratio that varies between different soils on where your Cal-Mag ratio has got to be. In a sandy soil, you have more magnesium because you want some structure, because that tightens up the soil, to a soil that has no structure. So a 3-to-1 ratio is the Cal-Mag ratio in a sandy soil. But when you get out to heavy clays, you go right out to 7-to-1, 7 parts calcium to 1 part magnesium, because you want more calcium to open it up and less magnesium to tighten it. So that's the physical link to gas exchange and breathing, opening it up, having the right ratio and having enough magnesium to have a green plant. And the biological link, because it's always about minerals and microbes, is the fungi to bacteria ratio. So bacteria spit out a sticky little substance that creates a tiny little aggregate, a tiny crumb in the soil, and fungi are the only creatures that can take some of the bacterial thing and that crumb, and they wrap with their hyphae and create this much larger crumb, sometimes tying together humus and clay together, creating this very stable humus, but creating crumb structure. And crumb structure is the most desirable of all soil types. In comes the oxygen, out comes the CO2, earthworms can move through unimpeded, the plant root can move unimpeded, moisture comes in, you've got infiltration, a really important word in the brave new world of climate change science. How fast does it wash the soil off the soil versus soaking into the soil? And that's infiltration. How much water can you take in per hour in a strong rainfall event? The huge issue that the planet's facing at the moment is the fact that we're losing 7 to 12 tonnes of topsoil per year, and it's speeding up because of climate extremes. So at that rate, we've got 55 years and there's nothing, 0 topsoil there. So we've got to have a bit more focus upon our soils. And why are we losing so much? Why is it all eroding? Because we lost the glue, and the glue that holds the soil together is called humus and organic matter, and we had 5% organic matter in 1900, now we've got 1.5%, we've got no glue, the rivers run brown following a rainstorm event, the ocean fills with dirt, and we need to bring back the humus and stabilise that soil and protect the most precious of all substances, much more precious than gold and diamonds and lithium and whatever. because you don't survive without topsoil. You can say, oh, I can grow food hydroponically. No, you can't. It's crap food anyway, but you can't feed 10 billion people hydroponically. You've got to have soil, and we've got to realise that there's nothing more precious and more valuable than that soil. So, where are we at?
Well, how many minutes have we got left, please? 7.5. So,
7.5 elapsed so far.
Oh, so we've got
laps, so we got plenty. So when we get closer, if you would like to get up and have a proper look at what we're doing here, so you can see. You probably have to explain about the cards and.
Have you got your?
I'm all ready.
Yeah, I've explained that, so that's good.
So because then you can see we're putting 3 drops on this card, and then we're taking a photo of it, and the magic internet tells us what the result is. But between the first one and the second one, there's only very little time because mine is set for the second one.
Okay.
So the first one is the.
Remember, halfway through you give it a little bang.
Yep.
Both of them.
About 12 minutes.
Yeah, that's it. So 12 more minutes, we'll do that.
The first one we're going to test is worm carbon, and this is the lead check.
Okay.
And there's our card. All is good, I think.
Okay, so in 12 minutes we'll do it. So we got any questions on anything to this point? Yeah.
You said you were going to test the paramagnetism of...
Yeah, we can do that now. It's a good idea.
I think I've read that it's quite high.
Yeah, I picture it would be because it's volcanic soils, you know, so all volcanic soils are high. I'll just grab a little bit of soil over here.
That's
Okay, so you first of all you've calibrated so it's on 0, then you take your little film canister full of soil and drop it in there, and it measures 65 times 10, 650. So a poor soil's 0 to 100, a good soil's 100 to 300, a very good soil's 300 to 700, and we've got 600 and absolute superior 700, 1200, so we're in the very good soil category for the paramagnetic qualities of it, and that could vary. That's just that test. So yeah, sorry.
What does this one score?
650. And we might find that it's pretty simple to test. We can test it underneath the crops. We can test it on different soils. You can actually wear out the paramagnetic effect. Like they can test places like on the top of some of the mountains in South America where they carry the water on their heads and watered it, and you'll see that over a period of 30 or 40 years you actually depleted the paramagnetic effect just from watering and cultivating. So it'll be interesting to try a couple of other spots. It only takes a minute to test, and we'll see how we go, but that would be considered to be a pretty good soil. So what you've got is amongst the highest organic matter on the planet at 12% average based on all those tests we did, and you've got what's classed as a very good soil paramagnetically, and all you're lacking is those 4 or 5 minerals. But to be growing 15 or 17 hectares of food on a bountiful, appropriately called the bounty, a lot of the things, but is almost criminal. You need to start growing food. Anyone can do it. You just need to correct those minerals and find out what you need, put it in there, and you've got this beautiful base to grow wonderful food, as Matt Biggs is doing so beautifully. And Matt himself says people have got to grow food. You've got to have food security. You can't have 12 hectares on a whole island of food that you could grow, 1,000 hectares, no problem. There's that good a base here. It could be a bread bowl of the Pacific. Theoretically, you could be exporting food. It's that good. Yeah, you could be applying. You could be literally. It's a huge opportunity that's not been recognised. The only thing about it is that you've got to like work. To grow food, you've got to like work. If you don't like work, forget it. And there's a whole generation of people who don't necessarily like work. Some of them find they do. We've got lots of young people who are so insanely passionate. I bought an RV, these big homes, because I was travelling around, flying to Sydney, fly to Coffs Harbour, back to Sydney, back to Brisbane to do talks. So we bought this big one, you push a button and the sides come out, we put a couple of electric bikes on the back, and we did like 12 seminars at one hit. But we go down this place called the Nambucca Valley for these young people in their mid-20s, and there's a whole group of them down there growing and selling at the markets. And oh my God, I mean, you hear that there's things like Shangri-La. You're driving through this valley 30 kilometres on a dirt road. The river running beside the road is this deep and completely crystal clear. They drink from it directly and it's just this perfect water. So there's still places like that that exist. And they're growing. There's a guy doing mushrooms and he does lion's mane into a powder and does really well with it. And they're growing, doing this beautiful thing. And they're in this paradise. And the couple who are there, you know, who are probably might be probably 30s, lovely, intelligent, passionate couple growing food and loving every minute of it. And they balance their lives. So they go overseas in the winter when they don't, or in the summer when they don't. It's not good in the coast to grow in summer. There's not much you can grow. But they grow all of their crops in winter, sell it, make good money, and then go off and have this nice lifestyle where they have 6 weeks overseas. And you know, it's a pretty nice lifestyle when you look at the people sitting in the cities. I mean, obviously you've not got that style here, but you're sitting, driving for an hour and a half in this crazy traffic, sitting there in front of a square box with someone here and someone there, and then driving home again. It's a half life. You know, compared to growing food, there's just nothing like it. But my issue is that these people, these wonderfully bright, intelligent, aware people doing the most important profession in the world, producing food, are not planning to have kids. And I said, why the fuck not? You know, you're the people, oh, because it's not a good world to bring people. Yes, it is. You need to bring people, the people who can inculcate those kind of values in their children. They need to have kids yesterday. Anyway, they smiled when I asked them in the most recent little talk I had on Zoom with them, and I think they might be working on it. So,
Yeah. How many more have we got?
15 minutes of a lap.
Okay. 5 minutes. It's funny how time goes slow when you're waiting for it. It's like waiting
so the deal, if you just want to do a small, if you can get one of these things, unscrew the top, to do that small version of a 20 litre brew, that's perfect. You know, you've got this one-way valve already built in, so that's just a home brew kit. You know, really handy from that perspective for, you know, any of the anaerobic brews. But the aerobic brew is a different story. And so the aerobic story is to use a little, this Phil's thankfully produced for us, it doesn't have the air stones on it, does it?
No, they.
So you can buy these little dual outlet fish pumps for 20 bucks, 25 bucks, probably dearer here, but, and you, 35, did you? Yeah. So, and on the end of it, you put he hasn't got them on there anymore, but on that you push this little stone, it's called an air stone, it's a little cylinder that's made of some pumice material and just sends out thousands of tiny bubbles. The essence of brewing beneficial microbes is that they're all highly oxygenated except for these beneficial anaerobes, and they've got to have lots of oxygen. The oxygen is all about, it's not like swirling it around with a pump, it's about tiny bubbles and lots of them, because the smaller the bubble, the greater what's called dissolved oxygen, because there's more surface area to create dissolved oxygen, so you need lots of little bubbles. So a dual outlet with the air stone on it is just a mass of millions of bubbles. And the standard deal is like in this instance, and just to give you some idea of the possibilities, this is one of my favourites, and we use it all the time on the farm, but it's called Microforce. So the most productive of the beneficial bacteria are bacteria of the Bacillus strain, and some of them you might have heard of, something called Bacillus subtilis, for example, controls powdery mildew, downy mildew, and stimulates plant growth and plant immunity. But there's another one that's even hotter at the moment in the research world called Bacillus amyloliquefaciens. People call it BACAM, the farmers do. People are familiar with these names like football players' names now. People talk about microbes in the pub. It's got to that kind of level. It's wonderful to see. So this is a blend of 5 of the most productive bacillus organisms. All of them fix nitrogen, which means you get nitrogen for free from the atmosphere. So they make an enzyme. They convert the gas to ammonium nitrogen in the soil. All of them solubilize phosphorus, and this is massively important for your soils. The biggest problem on Norfolk is iron, and that red colour is iron oxide, and iron ties up phosphorus, and you can't really grow without soluble phosphorus. That's what we looked at this morning, was the lack of phosphorus on lots of plants. That causes that stunting.
3 minutes to go.
Okay, so basically every bit of phosphorus, even chicken manure that they put on there, ties up and becomes iron phosphate, and you need phosphate solubilizing bacteria that can make it available again. That's what these things do. They fix nitrogen, they solubilize phosphorus, but most interestingly, they produce an enzyme. Anything with an enzyme has an ase on it, like lipase or lactase digests lactose, for example, the milk sugar. So it means it digests it. Well, there's a thing called biopolymers. The most abundant you're looking at now, it's called chlorophyll. the most abundant biopolymer on the planet. Second most abundant is called chitin, C-H-I-T-I-N. And chitin is every fungi, which is the biggest, most dominant of the, because they're much bigger than bacteria, obviously, and every insect. Insects are 75% of all life forms, and their outer skin is made of chitin, and the fungi's outer cell wall is made of chitin, and even a caterpillar's gut lining is made of chitin. So chitinase digests that. And what's weird is that it doesn't take out the good guys. And so chitinase has become this really hot thing in agriculture, and these guys make it. So you can brew this up, and you've got a fungicide, you've got an insecticide, you've got a plant growth stimulant, you've got nitrogen fixation, so this is what I mean about this exciting potential of do-it-yourself living fertilizers. You take a freeze-dried powder. We won't do it because we haven't got the power, and we won't waste your...
Far more into it.
Yeah.
We're going to do this little test.
Just about ready now?
Yeah, now. So if you would like to come closer.
I'll take it up straight away.
So that was the thick one, was it? Okay, so that'll be interesting to see. So 27.3 is, it's on the borderline of being good. It's not fantastic, but we'll see.
We also stuffed around a long while, didn't we?
Yeah, I don't know if that makes a difference or
true.
not. That's true. It could
Yes.
be.
Yes.
He's got the
You're
time.
welcome.
So this is a different. This is a different one. So this is just the leachate now.
This is the weed, the leachate.
The juice.
Yeah, the juice that drips out, Yeah.
Yeah, this isn't the thick one. This is the one
See, it's supposed to, like normally,
You don't have to. That's it. You got it.
normally it just does it all by
Is
itself.
it, but it's just calculating. Yeah. So the leachate is 11.1. So it's twice as good. But so 11.1 is not very
Two
good.
times better, the poo.
Oh, 2 times good. It's 28. Or 2.5 times better.
What was it?
Yeah, 28
Yeah.
versus
Nearly
11.
3 times better to do the actual.
Yeah, that varies between different vermicultures, but you can see the story. The extract is the way to do it, and you'll do the same thing with the compost tea
Otherwise we
versus
use the same
a compost
amount.
extract. You know, if you can just swirl it round and beat them off their humus, it's the highest concentration. So it's a great little tool to see how that works.
Yeah.
Yeah, it's good how it works, eh?
Oh,
Yeah, it's a nice chocolate stuff, beautiful stuff. Yeah.
bubbler, the fish.
So what we'll do, did we end up getting our mic? Oh, we did get the refractometer back, so we'll have a little bit of walk down to his crop there and we'll measure and show some in-field monitoring. Just what time we got?
Well,
The small bubbles.
it's 10 to 4. I'm
Yeah.
just going to... The critical point here is that Tara is the bus driver and Tara needs to be back by now.
Oh.
No, we can go another half an hour, I reckon.
So we'll walk down to the closest, that nice paddock. Where's Phil? That was the nice part that you just sprayed with something the other day.
Yep.
And we'll do some little infield monitoring. We'll show you how to do a refractometer and how to do a couple of other simple tests, including perhaps one of these readings on the actual soil right beside the plant roots and see how they're doing.
So you want to
Yeah.
take your
Got the
reef back.
towel.
Calcium's called the trucker of all minerals. It's directly responsible for the uptake of 7 other minerals, and that's why you always got to fix your calcium, or try to fix your calcium. So this is a calcium meter basically, and quite a reliable one. So we'll have a little bit of a quick look because we've got to get moving, and we'll take the leaf that you always choose is the first fully developed leaf on the plant. And so if you're looking here, that's not it. That's probably the closest, and that's the leaf we would choose for. I'll let you hold this for a moment for me. And so you grab the leaf that you want involved, and you roll it up a little bit and bruise it a bit, like so. I don't think we're going to need that.
You got the
I don't think we'll need it in this case because I think this. But
Well, it never works,
okay, we'll
so
do it.
there's the
Okay.
thingy.
So you get a little bit of gauze. This is just you can't use cheesecloth because that will suck up the liquid. This is this nylon curtain liner. You buy a square metre and cut it up,
So
and you,
Vincent de Paul is awesome.
yeah, and then you poke that in here, and that isolates the mulch that you'd otherwise get. Then you wrap this into here.
Probably got a bit much there.
Probably a bit much, but we'll see.
Garlic press, right, Graeme?
Yeah.
And then we get someone who's got strong. We get Phil in here with his windsurfing hands.
Phil, get the squeeze happening there. So see how that brings
See the juice
out?
coming out? Oh, you got to get it, hang it over the top. You just missed most of it there.
It's all right. We've broken many
You
of
need
these.
5 cents?
Where's she going? Where's-
Close.
Squeeze, mate.
I can't get in.
Oh, he's got
Can't get it.
the first
Need
bit.
5 cents?
That might be enough now.
That'll do.
It's close enough,
I
I
have
think.
a weeny bit much stuff in there.
Yeah.
I think it is too much.
No, that'll do it. Let's
do.
film the film.
It's flat.
So when you look there, you see the two halves and you see the central axis, and it's quite low. It's only like 4 or 5.
Oh yeah.
And you can also see a sharp line, so there's desperately some need for calcium. The biggest thing that would lift bricks is just getting some calcium in there.
Yeah.
Yeah. So that line where it crosses, where it says 4 or 5 there, can you see the two halves and where it crosses? That should be really blurry, and it's quite sharp and distinct.
So I need some trio.
Yeah, you do.
4 or 5.
Yeah, and it should be above 12.
Yeah, very low.
Yeah, and hence we've got a few bites.
Do you want to try anything else? Do you want to try different?
You want to try zucchini?
Yeah, we can do that.
You want that one?
That'll be the first fully, wouldn't it? Yeah, that'll be good. Probably need a bit more than that, probably.
Have you got another piece of cloth, Miller?
Yeah.
We never used to use a cloth.
No,
Yeah, it's
because
just an easier way
it
to do
does
it.
such a smoosh. Should we rinse this through?
No, you don't
Because
need
it's going
to.
to be distorted, isn't it?
You can see there's nothing there that's going to worry out very much.
Graeme, where would you get, what's the best to put on there to get the calcium?
You can just use something like calcium nitrate if you want, and what you do is mix this natural substance called fulvic acid with it, which creates what's called a calcium fulvate, and you're only using like 2 kilos, it's like $1.
And put it onto the foliar.
Foliar, yeah, it's just absorbed. See, calcium is the most immobile of all minerals, it's the slug of all minerals, and there's a whole variety of things that govern its mobility, and one of them's fungi. Fungi are really important in that equation. And so it may well be that because it's been cultivated so many times, fungi hate cultivation, and you slice and dice them every time you cultivate, and this just gets cultivated constantly. So it may be way down. We haven't got 20 minutes to test it, but I'm picking that it's got really deficient in fungi, which means poor calcium delivery. And then you've got calcium governs the uptake of 7 other things, so you've got low bricks, because both of them are showing up on the meter, sharp line, which means calcium deficiency, and low bricks, which always come together.
So what do you read out of just looking at the soil there?
Basically that everything is involved cultivation, and cultivation is really bad for fungi. They just slices and dices, and they hate the intrusion of cold steel and earthworms. And you're far better off to build a mulch, to put a big cover crop in here, cut the cover crop and plant into the mulch and not cultivate it. It's so much better. Yeah.
Excuse me, Graeme, what's the difference between, when you look through the refractometer,
Yeah.
when it's a fuzzy line, this is very fuzzy.
No, that's not very fuzzy, that's quite distinct.
No, not now.
Oh, have a look. Oh, this is for the other one. Okay. Oh, this is the new one. I haven't
yeah,
seen
we
this.
haven't finished looking at it.
Okay.
So this is quite fuzzy,
I haven't
but there's
seen
a
this, though.
difference between a clear line and a fuzzy line. What is that?
That's calcium, yeah. That was just what we were just talking about. The sharp line is calcium deficient, the fuzzy means. So in this instance, that these ones, which are actually, the brassicas need a bit more calcium, but these ones have got enough.
No, but we haven't done
Oh,
it.
you haven't done
What
it?
I'm telling you, we're still on the old bit.
Okay, so okay.
It's actually changed as we've been looking at it.
Yeah, it's dried out, that's why. So,
Okay,
yeah,
so now we clean
just
it?
wipe that off, yeah. The initial reading is the important one when you've only got a tiny bit of sap on there.
Is there going to be much of a difference if you take it's late in the day,
Yeah.
you take a leaf sample that's been out in the sun for the last few hours?
Yeah, I mean, so basically, when I'm measuring bricks levels, because I want to feel good about myself, I always measure it late in the afternoon, because the peak is you could go down there and grab one for sure. The peak is about 4:30 is where it reaches, and then it starts pumping down the sugars from about 4:45 onwards, starts pumping some back to the root. So the highest bricks level is always like later in the afternoon, but here, because sunlight's part of the equation, it could be a little bit different in the sun.
Quickly, this is zucchini.
Wow, it's quite low, isn't it?
I don't know, you're
Yeah,
the first one
yeah.
seeing it.
Just dripped it all over you, I think.
Oh, that's,
Yeah.
Phil, it's yours, your crop.
It's terrible, isn't it?
Yeah, so it's really low.
Did you see what number it was? Was it 0?
0,
What number was it? Was it 0?
I can't really see a distinct line.
Yeah, but it's right there.
That's a cabbage that was in the sun.
Okay, so we're now we'll next check a cabbage that's been in the sun.
But
They look good. You know, if you look at them, they don't look like
Is that the last
Couldn't
one?
you read a number on
But
that?
what it will be is whether or not they get powdery mildew and how resilient they are, and they're only just young plantings. So that's, you know, the higher the bricks level, the less likely having those issues later on. That seems strange. I hope that refractometers are right because they do look all right, don't they?
They do look
Yeah.
well, I
They
thought
look
they
great.
Pretty healthy.
Yeah, I
but,
reckon they're looking good.
What have we done wrong? Have I done something wrong, Graeme?
No, you can't really do anything wrong other than
I've
there
always
being a
done it in the
mistake with it.
mornings, but
So we'll try a little bit of this with
this
the
afternoons when these have really struggled, these cabbages there, but they're not looking too good.
Yeah, maybe not too much.
that will be right. You should be able to squeeze it out of that, but you've got to be there first off to do it.
Hang on.
So we've taken the cabbage from down in the sun because the sunlight is photosynthesising and theoretically might be a little higher. We'll just see what the highest bricks level in the day will be.
Here we go.
Last thing in the afternoon, about 4:30 in the afternoon, will be the highest that you'll measure all day because you've photosynthesised all day, and then the plant starts giving away some of those sugars down to the roots, and so the bricks level drops overnight.
I didn't know you could swear.
It's just got to have it level.
You get it level that way so it doesn't drop. Yeah,
Oh, that's so
that's
much.
plenty here. It's going to work.
Didn't know ladies used to
I never said that thing.
Yeah, so that's again, it's still about the same, the 3-4 level, but it's quite distinct, that line. So calcium's the story.
That's better.
So
Yeah.
what do we really want? 12 at
The
least.
12's what you want. Yeah.
That's cabbage from the sun.
So, you know, it'd be really good just to do a tissue test and just find out exactly what it is you need because you're just driving blind. You don't know what really there could be. Anything could be needed in there.
Especially after an inch of rain.
Yeah, that's right. It could well be potassium as well because it carries sugar in, and it's very leachable. You've got to leach it all out. Anything's possible.
I find after rain everything just washes it out a bit.
Yeah.
Because the other day it looked really green. But,
Who on the island has a refractometer?
Oh, you've got one, have you? Oh, good. So they're only inexpensive. They're like $60 on Amazon and things like that. So it's an inexpensive tool to just be able to see how you're going.
is that tower down there?
Yeah, we'll just have a quick look at that before they go. The other thing with a refractometer is that it should always measure highest in the afternoon, and there should be a drop of 2 or 3 points first thing in the morning because you pump down your sugars and you're measuring sugars. And if there's not a drop, that's an indication of a boron deficiency because there's a little trapdoor that opens that allows the translocations for the sugar from the sugar factories down into the roots, and that trapdoor is governed by boron. So a boron deficiency will kind of constipate the sugars in the leaf and not translocate them, and you'll see the same bricks in the morning as the night. Then you need to come up with some boron because that's quite serious. You stop feeding your microbes. They're all hanging out open mouth waiting for their feed of sugar, and it's all ground to a halt just because you couldn't open that door to translocate the sugar, and that's boron. So the refractometer tells you calcium, it tells you your skills as a chlorophyll manager, and it tells you whether you're boron deficient. Quite a handy tool.
Power?
Oh, we'll have a quick look at the tower, yeah. Thanks, mate.
Thanks, Graeme.
Thank you, Phil, for allowing us to come out. It was lovely. Great to catch up.
Quick thank you on behalf of us.